everyone. Today again I am here with you with 10th class physics, the left out part, that is your refraction of light. So let's go ahead. Refraction of light. First of all, I will define refraction. What is refraction? Refraction definition. It is a phenomenon of bending of light when it passes from rarer medium to denser medium, or from denser medium to rarer medium. Now let me tell you what is rarer medium and what is denser medium. A medium in which the particles are far away, for example air is a rarer medium and water is a denser medium, glass is a denser medium. So optical density increases when from it gas to liquid, liquid to solid. Okay, so this is refraction of light. First of all, I'll let you know how the refraction is taking place through glass slab. So let's go ahead and draw the diagram of refraction through glass slab. So for this I have to draw a diagram which is your refraction through a glass slab. This is your glass slab. Let ABCD is the name of the glass slab, and an oblique ray of light is passing and making an angle of incidence I with a normal. It is always bending toward the normal. When a ray of light is passing from rarer to denser, rarer is your air and this is your glass. So light will bend toward the normal. And when light is passing from denser to rarer, it will bend away from the normal. This is called angle of incidence. This is angle of refraction. So this is also angle of refraction and this is called angle of emergence. Here angle I is equal to angle I is always greater than angle R, and angle I is equal to angle E. Okay, so like this you have to remember. Let's talk about the laws of refraction. First of all, I am talking the first law of refraction when refraction is taking place. So laws of refraction. First law of refraction is same which is there in the reflection also. The incident ray, a reflected ray and the normal all exist in the same plane. The incident ray, the refracted ray and the normal all exist in the same plane. Same plane means if the ray of light is coming in the plane of the board, it will bend in the same plane. It will not come out of the plane. So in another plane. So this is first law. Second law, the second law of refraction. Second law of refraction. Very simple. It is also called Snell's law. You can write in bracket Snell's law. It is the ratio of sine of angle of incidence to the sine of angle of refraction. So mu, we call it a refractive index, is equal to sine I upon sine R. refractive index, it is represented by mu is equal to sin I upon sin r. So these are the two laws of refraction. So we call second law as Snell's law. First law is same as that of law of refraction. So any one of the law or both laws can come in your exam. So let's go ahead. Refraction through glass slab already I have discussed, and I'll go refraction through refraction of light from spherical mirrors, SPHERI, spherical lenses. Spherical lenses. So basically two types of lenses you have to remember. One is your convex lens. Convex lens. This is also called as double convex lens. And another is your concave lens. Concave lens. So this is your concave or double concave. Concave lens. So today we are going to discuss first of all concave lens. It's having two cases and it's having 6 cases. Two cases are there in case of the mirror. Which one is your convex mirror? That cases you will follow here in concave lens, and which cases you have studied in concave mirror that will follow in convex lens. So formula little bit difference will be there. I'll let you know later. So let's discuss one by one cases of spherical mirror. If you can remember the cases of the mirror, you can easily solve any type of the numerical. So fine, numericals are generally asked in the examination, so I am stressing upon your cases. First of all, spherical lenses. There are some other lenses also which are not in your 10th class syllabus. We call it plano-concave lens. Plano-concave, just for your knowledge I am telling. Another is concavo-convex. Plano-convex, like this. This is your plano-convex. Plano convex, but they are not in syllabus, so you can just omit it. No need to just go for it, and just only remember concave lens. So concave lens is also called as diverging lens. Diverging lens. Fine. So this is your x, y, you write aperture, and this is your pole. Center of this is called optical center. X dash and y dash is the second side of the spherical. This is cut out part of the spherical glass. Fine. So spherical lens, first case we are discussing of concave lens. So in case of the concave lens, first case is when the object is at infinity, INFI and ITY, means at large distance, than the size of object. This type of lens, concave lens, is always making virtual and erect image. You have to remember. And the ray of light always we take from the left hand side. So suppose this is a ray of light which is coming from the infinite distance and it is diverging. Basically I have written here it is diverging lens. So it will diverge. Diverge means moving out. So you have to just only trace back dotted, and where it will meet, that point will be called as your principal focus. That will be called principal focus. You can write it F1. Similarly, if a ray of light will pass from this side, so principal focus can be made that side. But we will be taking sign convention. All the things to the left hand side will be taken positive. To the right hand side of the will be taken positive, and to the left hand side will be taken negative. Above the x-axis positive, below the x-axis will be negative. So what will be the nature? The nature of the image will be of image formed is virtual and erect, highly diminished, point, comma, highly diminished, point sized, means point sized. You can write point sized also. Point sized at the focus. Focus. So this is your focus. At this focus, your ray of, but this type of image we can never obtain on the screen. Whereas real and inverted image we are able to make on the screen. If you will place some screen, you cannot obtain the image. So because this is virtual image, virtual which appears to us, which cannot be formed on the screen. So this is the first case. You have to remember the nature, you have to remember the case and the ray diagram, how it is formed. Okay, if the case will come as it is, you will be making in the exam, and 1 marks for the diagram and 1 marks for writing the nature you will get. So the second case, let's go ahead from the concave mirror. Case number 2. Let's do the case number 2. Case number 2, refraction from concave lens. This is your concave lens where the object is placed. When object is placed at a measurable distance between infinity at any point in front of concave lens. So again, x dash, y dash, optical center O. I am placing it here. Let us name the object as AB. H is the height of the object. Draw the ray diagram parallel to the principal axis. Diverge it outside, and this will be the produced back. Focus dotted. Second ray of light will pass from the optical center, which will not bend at all and will pass directly without bending. AB. Why without bending? Because the width of the glass on the both sides is equal. So you will see which type of image. Again, virtual and direct image. Nature, virtual and direct image of smaller size than the object is formed between F and O. Always F and O. Between focus and optical center, this image is always formed. So these are only two cases in case of refraction from the concave lens. Let's go ahead with convex lens. There are 6 cases, and with that your topic will finish. Refraction from convex lens. So this is your double convex lens. Sometimes it's written double convex, sometimes it's written converging lens also. First case, case number 1 in this, when object is placed at infinity. Is placed at infinity. This is aperture and ray of light principal axis, which is passing from the principal focus. Here principal focus we can write f1, f2. Double of the distance is written as 2f2, and here 2f1. So when the object is at infinity, ray of light will come parallel. It's converging. Will converge here. You can make one from this side and will converge here. So this is your image is formed at the focus. So you are supposed to write the nature now. Just only 2 things you have to remember: the case and its nature and diagram. So real and inverted image is formed at the focus, highly diminished. So this is highly diminished image formed at highly diminished image point size at the focus. So this is the case which you will be making. I will be making the second case here only, case number 2, when the object is placed behind 2f2, behind, behind 2f2, where the image is formed. Just see A, B, very simple. We are coming close. So the image, second ray of light will always pass from the principal focus, where they will meet. There your image will be formed. Just see the image where it is formed. let this pass here. So your image will be formed here, A dash, B dash. Which type of image? Real and inverted image is formed between F2 and 2F2. Between F2 and 2F2. It's not highlighted in English. Between the formed between F2 and 2F2. Smaller in size than the object. Very simple. So similarly, when you will go little close, it will be little far away. Image will be formed. If you will place at 2F1, it will go at 2F2. Very simple. This is your distance of the object. This is your distance of the image. Fine. And the focal length of this is positive. Convex lens is positive, whereas concave lens is focal length is negative. So third case, when the object is placed at 2F2. So what you will do? You will pass it from here to here only, and the ray of light will pass from here, and you will see that ray of light will meet. When the ray of light will pass from the optical center, it will just meet little far away. So from the center you should make, and it will be formed at this point. So like this your image will be formed, A dash, B dash naturally. So V will little bit increase. Here U and V will be of equal size. U will be your negative, whereas V will be your positive, and focal length will be also positive. Fine. So H will be equal to H dash, because height of the object and height of the image will be same. It is the same case. So real and inverted image is formed at 2F. At 2F1 we have placed. Object is 2F1. So 2F2 you can say. You can write either F1, F2 this side or this side, your choice. Fine. So this is case number 3. Similarly, I will go a little closer. So image will go a little far away and larger size of image is formed. I am erasing it, and let's make a new diagram. Make it better. Case number 4. Case number 4. When the object is placed between F1 and 2F1. Let's draw a diagram. This is your aperture, convex lens. So this is your F1, this is 2F1. You will place object here. Ray of light first will go parallel and will pass from F2 always. And second ray of light will pass from optical center. Let it meet where it is meeting. So this is your 2F2, and your image will be formed just outside 2F2, A dash, B dash. You can write H dash also. This is your B here, A here, U is this, and B is this. So this 2F1 is double of, if focal length is 10 centimeter, that means 2F1 is 20 centimeters. Similarly here, so U you will be finding in between them, and V accordingly you will be getting. What will be the nature? Again, nature is real and inverted. Real and inverted image is formed beyond 2F2, larger in size. Larger in size, or you can write magnified also. Magnified also can be written. I'm writing in bracket. Fine. So let's go for case number 5. When we are going more closer, we are going suppose on F1. The image will be formed at infinity. That will be also real and inverted. Let's modify from here only. Case number 5, when the object is placed at F1. The image, what will be the nature of the image? Let's modify this diagram. Only from here, you are coming here. This is your object. Let's name it AB. The image distance object distance will decrease. Let's find image. Image will be formed at infinity. Let's see how. Little bit modification required. So this is your f1. This pass like this. Sorry, this is your f2. So your image will go at the infinity. V is equal to infinity, infinite. So both these rays of light will go parallel and will never meet. So image nature, the real and inverted image is formed and highly magnified, highly magnified at infinity, So this is the way how we are making. Only one case is left, that is your case number 6. That is the unique case, that is of virtual and direct type of image is formed, not real and inverted. First 5 cases are real and inverted, last case is virtual and direct. Let's form the last case. So here come your case number 6, when the object is placed between F1 and optical center O. So here this is X, this is your Y, this is your F1 to F1. Let's draw it here. See, the ray of light will bend from here and will pass from F2 always. So this is your F2, suppose. So you have to produce it back. And another ray of light you will be passing from the where? From here and trace it back. Where they are going to meet. That point, meeting point, will be called as the image is formed at that point. So you will draw with the help of a scale straight lines. So here your image is formed, A dash, B dash, arrowhead over here. So this will be V and this will be U and this will be F. Only F is positive, H dash, U and V in this case will be both negative. So let's write the nature. Sorry, this is virtual and erect image. Is formed on the same side, larger in size, magnified. On the same side, of the object. So this is 6 cases. If you can remember these cases, then you have to just write down the formula. If you know the formula of refraction, you can solve all the numericals. Just I'll let you know the last thing. So refraction formula. So we call it length formula also. 1 upon F is equal to 1 upon V minus 1 upon U, where F is your focal length, U is your object distance, and V is your image distance. And your magnification formula, you have to remember magnification formula, M is equal to V upon U, or H dash upon H also you can write H dash upon H is equal to V upon U, where F is equal to 2 times F is equal to R, or you can write F is equal to R by 2. If you can remember these formulas, with the help of these formulas you can solve all type of numerical. So numericals I'll be taking into the next session. So that's all for today. Please subscribe my channel and share it as much as possible. Thank you very much.